In today's information age, data and information is passed between individuals and companies in ever-increasing amounts over the internet. A lot of this information is confidential and needs to remain that way. Encryption is used to protect data by scrambling up the message or data and so protecting what the message is actually saying. On this slide we can see some examples of encryption. A meaning can be hidden by replacing words with symbols or speaking in code. In the film White House Down, security guards are often speaking in code to hide the meaning. So Olympus is down meant the White House had been taken over. Sending out the full package was that the president and his family were about to leave his house, and sparkplug received was that the president's son was safe. Morse code, unless you understand the series of dots and dashes, the message is meaningless. To encrypt messages being sent over the internet, a piece of software called a key is used. Depending how complicated you want the encryption to be will depend on the size of the key. A 40-bit key will give a possible 1,099,511,000 combinations. A 128-bit key can produce over 339 decillion combinations. That's 339 and 30 zeros after it. This slide is demonstrating that any message being sent over the internet can at any point on its route be listened into. This is why encryption is necessary. A major advantage in everyday life using the internet is that purchases can be made. However, making any internet purchase requires sending confidential information to that particular shopping site, like Amazon or eBay. Such sites need to be secure. The user can see that these sites are secure in various ways. In the browser, HTTPS will be followed by the website name. In the bottom right of the screen, a padlock can be seen. By double-clicking on the padlock, information about the website security can be seen. By having an encrypted site, it allows secure messages to pass between two computers. Anyone trying to listen in will only receive a garbled message. There are two types of encryption methods, these being the public key and private key methods. Here are a group of people who want to pass information securely between themselves. To do this, they are going to use the public key method. Here, all of them have an identical encryption key. This key can both encrypt and decrypt messages. Provided you have this key, all messages between these people can be read. The problem with the public key method is that if someone's key is stolen, then the thief can decrypt and read everyone who uses the same key. In short, everyone is affected by the loss of a key. The private key method is much more secure. Here, everyone has a public key, the one shown above the people. The public key still allows people to send encrypted messages to each other. However, the second key underneath the people is the private key. Everyone has their own private key. This key is the only key that can decrypt their public key. The advantage of the private key method is if someone loses their private key, no one else is affected, except the person whose key has been stolen. Now, let's put it all together and see how it all works in the real world. Bob has a business selling bikes. Peter is keen to buy a bike. If there is no secure method of payment, somebody else could pretend to be Bob's bike's business. As a result, Peter could send his personal details and money to the wrong person. What is needed is a way of making sure the person you are sending your details to really is that person. So Peter needs to be sure he is talking to Bob from Bob's Bikes and no one else. A method of making sure that the identification of that person is genuine is by using an organization called the Certificate Authority. The way it works is this. Bob needs to prove to his customers he is who he says he is. Bob gets in touch with a certificate authority like VeriSign or GlobalSign. They do checks on Bob, getting evidence he is Bob, that he has a real business and a real website. When the certificate authority is satisfied that Bob is legitimate, they will issue him a certificate. Not a paper certificate, but a certificate that is represented by a long string of numbers. These numbers are a condensed version of Bob's various details. This certificate is put into Bob's web server. Now, with this digital certificate in place, Peter can make contact with Bob's website. Whilst Peter's computer and Bob's web server are connected, Bob's web server sends the certificate and public key to Peter's computer. Peter's computer is able to see that Bob's website is genuine and allows Bob's public key to encrypt Peter's personal details, which is sent to Bob's web server. Bob's private key will decrypt this information and he will be able to sell a bike to Peter. In the end, nearly everybody is happy. Peter gets his bike, Bob gets his money, and the bad guy gets nothing.